Alright, today we're looking at parallel and perpendicular lines, and for each of our lines that we are going to write today, we're going to write them in slope-intercept form. And just like all of the lines that we have done that have been written in slope-intercept form, there's two things you need to know each time. The slope, which is m, the y-intercept, which is b, and if you know those two things, then you can write the equation for our line in y equals mx plus b form. And so for parallel and perpendicular lines, really what we're looking at is slope. Like this is just another way to find slope. And so in the past, we've done things like take y2 minus y1 over x2 minus x1 to find the slope of the line. This is the same thing. It's actually even easier. It's just a different way to find slope based on the type of line that it is. And so the first line that we are looking at are parallel lines. Some things that are true about parallel lines. First of all, just in general, parallel lines will never intersect. So you can see the example on the graph to the right. The blue line and the red line are parallel, like they will never cross each other. And so as we look at the equations of these two lines, for our red line, like we can see it starts here at 1. That's our y-intercept. And then for our slope of this line, it goes up 1 and over 2. And so our slope would be 1 over 2x. And so there's the equation for the red line. For the blue line, it starts down here at -2. And then our slope is up 1 over 2. And so our equation for our blue line is 1 over 2. And then that goes next to our x. So there's the equation of our two lines. So some things we notice about parallel lines. One is that we notice that the slopes is the same. Right? We notice that the slope is the same. 1/2 x, 1/2 x. So same slope, but our y-intercept is different. So same slope, different y-intercept. If it had the same y-intercept as well, then it would be the exact same line. But different y-intercepts make the two lines parallel. They'll never cross each other. So same slope, different y-intercept makes our lines parallel. So in our example, we're writing an equation of a line that's parallel to the one that's given. So here's our given line, y equals 2/3 x minus 1. That's the one we're starting with. So we're going to write a line that is parallel to it and goes through this point. So because it's parallel, well, let's start here. We want our new line to be written in this form, y equals mx plus b. We need to know two things. What's m and what's b? Well, we can figure out m really quickly because if the lines are parallel, then it has the same slope. And so our new slope is going to be y equals 2/3 x plus b because the slope has to stay the same. And so then we need to figure out the y-intercept, which is b. And so how we figure out b is we plug in for x and y something that we know is true. And what we know is true is wherever the line crosses through, those are true values for x and y. And so here's our ordered pair. X is always first and then y. And so x is 12, y is 5, and we can substitute those in because we know those values work because the line goes through it. So we have 5 for y equals 2/3, and then instead of x, we can plug in 12, because that's a true x value that works, plus b, and then we start to solve our equation. So 2/3 times 12 is 8, plus b is equal to 5, and then we're going to get the variable by itself by subtracting 8 from both sides, and we get that b is equal to -3. So now we know the two things that we need to know. We needed to know slope, which was 2/3 because it was the same as our original slope, and we needed to know our y-intercept. And now we can plug that back into our problem, and we get our final equation, y is equal to 2/3 x minus 3. So parallel line, different y-intercept that went through the point 12,5. That's the equation of the parallel line. Then for perpendicular lines, as we look right here, we can write our equation. For our blue line, our y-intercept is 1. And so we have y equals plus 1 is our y-intercept, and then our slope for this line is down 1, 2, and over 1. So that would be negative 2 over 1. So there's our equation for the blue line. And then for the red line, we have that it starts at negative 1. So down here, negative 1. And we go up 1 and over 2. So up 1 over 2. And there's the equation for the red line. And so some things that we notice about perpendicular lines. First of all, these two lines do intersect, and they specifically intersect at a 90-degree angle, or a right angle. So perpendicular lines always intersect in a 90-degree angle. And so we can see that they cross there. And then what we notice is true, always about perpendicular lines, is that the slopes are opposite. And opposite means one is positive and one is negative, right there, opposite. And they are reciprocals, meaning that whatever one of the fractions is, the other fraction, or the other slope, is flipped. And so we can see here we have negative 2 over 1 is our slope of this line, right? Negative 2 over 1. And this one is positive 1 over 2. So we have opposites, one negative, one positive, and reciprocals. One was 2 over 1, the other is 1 over 2. And so that's what's always true about perpendicular lines. Their slopes are opposite reciprocals. So one example here, and we'll be done with these notes, we've got that our line is perpendicular, so we know our slope right away, and we know that it goes through the point 2,4, so that's a true value of x and y. So we'll be able to use that to find out what our y-intercept is. So our new line, we're always going to write it in the form y equals mx plus b, our slope-intercept form, which means we need to know two things. We need to know the slope, which is m, b, the y-intercept. The slope we know right away because it's going to be opposite reciprocal of that slope. So our new slope is going to be y equals, and because this one is positive, our new slope is going to be negative since it's perpendicular. And then since this slope was 1 over 3, our new slope is going to be 3 over 1. So opposite reciprocal. It goes from 1/3 to negative 3 over 1, our new slope. And then we can finish the rest of our equation, x plus b. So now we have one part we need. We need to know slope. We have it. It's negative 3 over 1. And then to find b, we're going to take this value of x and y, and we're going to substitute it in for x and y in our problem because we know it's true since it passes through that line. So y is 4 equals, and then we have negative 3 over 1, and instead of x, we have 2 plus b. And then we can start to solve. And so first step is we're going to distribute. Negative 3 over 1 times 2 is negative 6 plus b equals 4. Then we need to get b by itself. So we're going to add 6 to both sides. And we get 10 is equal to b. And then we can take that and plug it back into our original problem. And now we have the two things we needed. We needed our slope, which is negative 3 over 1, or negative 3. And we needed our y-intercept, which was positive 10. So here is the equation of the line that is perpendicular to that line. Opposite reciprocal slopes, and then we substituted in x and y to find out what b was.